Hey everyone, Steve here at the Houston Championship team with 5990 TRIGON, checking out their amazing robot representing Israel here. And we're going to be looking through their entire robot. I have Nate, Ophir, and Lavi here to talk about their robot here on Behind the Bumpers.
This video on First Updates Now is made possible by viewers like you and also the following sponsors. SOLIDWORKS is free for first teams. Over 80% of US engineering schools and 370,000 plus companies use SOLIDWORKS to design great products. SOLIDWORKS can help you design a great robot on desktop or on the cloud. Go to solidworks.com/first to register your team. Get your off-season events an additional 25 to 100% more viewership by streaming it on Fun. We'll donate our Twitch or YouTube channel and help promote your event. Contact admin at firstupdatesnow.com to reserve your off-season date.
Nate, talk to me about your intake. You said you had a couple iterations, so talk me through that.
Yeah, okay, so this intake is seemingly simple, but it's able to do every single thing that we need. That was what we decided to do before the season and during the season. We wanted the intake and the entire robot to be as simple as possible while having mechanical proficiency. So this intake, which is incredibly simple, can do anything we need. We have a Falcon here with the gear ratio to make it stronger. It's just connected through two pulleys to spin these two that spin it opposite directions to suck in cubes and cones. We can suck in standing cones, fallen over cones, cubes, and anything. And the special thing about this intake is that it's not only an intake, it's also the end effector. Basically, we wanted to make the robot as simple as possible. And in order to do that, what we did is we made the intake also the end effector. And so we don't need to move it through tons of subsystems in the robot, and there's not much room for complication and breakages or difficulties in the robot. So we can collect and then just put the game pieces on the grid using this intake.
Now, can you demonstrate game pieces with this intake? It seems really small, so I just want to see how the cubes get in, how the cones get in.
So cones are pretty intuitive. It's two wheels, and you've seen a lot of intakes like this. Yeah, so enable.
Intake.
So the intake can do fallen over cones, just like that.
Oh, so it's not from the top, it's from the edge.
It can do all of them.
Oh, all of them.
Yeah, you can deploy. Now, if we're going to do a standing cone, it would look like that.
Oh, wow.
And it's collected. You can deploy. So the cube is counterintuitive, seemingly, because there's just wheels here. But we put the wheels at a very, very, very specific distance from each other, and we chose the compliant wheels very specifically so that they can pinch the wheels very, 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 very strongly and still keep it in. One second. So there you go. It's a bit of a scary sound, but trust me, the cube is fine. It doesn't move.
Wow.
And it's pinched in there really well. Now, at the beginning, what would happen is the cube would just fly out because it's a lot of air pressure and it's being pinched. It's just being pinched, not even held. So what we did is we, using the software, we measured the current. And so the current is constantly measured. And once the current spikes, because the intake intakes a cube or a cone, it slows down to what we call a hold or a pulse, where it slows very slowly. You can see it. The wheels are slowing very slowly. And this basically holds the cube and the cone in place throughout the entire transfer time of the cycle. And that's how we make sure that the cube, even though it's just pinched, stays in no matter what. We can also collect from the feeders, just, cones and cubes, because why not? We said that we wanted to do everything, so we can. So you can eject.
Really impressive intake, and I especially love that you guys are able to pick up the cones at different angles, at different placements.
Yeah, any orientation.
Any orientation, that's fantastic. Now, I'm going to give it to you, to Ophir. Tell me more about your wrist and your arm. We saw a little bit of the wrist movement. Tell me more about that.
So basically, in the arm, we have two Falcon motors back here that run through these chains up into these double sprockets, and basically allows us to rotate the first axis. We got an encoder over here to measure the degrees, and that's it for the first axis. For the second axis, we have a Falcon motor here into a versaplanetary gear going through these chains into this double sprocket. We also got an encoder there. For the limits, we have a limit switch back here, controlling the angle and letting it stop. That's it for the arm. This is actually our second version. Our first version had the motor inside of it, and it didn't work as well as we wanted to. So we took the motor out and made the chain go directly to the axle, and now it works a lot better and doesn't break at all, and it's a lot easier to access if needed.
Now, can we see the arm come out a little? See how your extensions work. So your arm seems to be at the perfect length to be able to reach all the levels. It's just the elevation.
Exactly. So it's basically all an autonomous function where we press a button and it extends and then closes when the driver wants to.
Right. All right, Lavi, I'm gonna hand it off to you. Seems like you guys have a keyboard for your controller, but tell me, we're gonna touch that later, but tell me more about your presets and how your autonomous and presets positions work.
Okay, so first of all, we control the arm by having a different, how do you call it? A different trajectory for each axis. So each axis is not disconnected from the other. We take into account that we want to open, first of all, the first axis, and only when we get to a certain height, then we want to open the second one, so the game piece doesn't hit the grid. We take into account also the height of the arm. So when it's closer to being horizontal, there's more force pulling on it than when it's perfectly vertical or down. So we need to accommodate that with applying a force that is relative to the position of the arm. We do that for both axes. For positioning it, we have PID and as I said, the trajectories. So we don't want to immediately aim for the position we want to go in. We slowly accelerate and decelerate. That's it for the arm.
Now, tell me a bit about, it seems like you guys have 3 limelights. Can you tell me a bit more about that?
Yeah, for sure. So we have a first limelight here, which is for April tags. We don't use the limelight software on it. We use photon vision because from the start of the season, actually before the season, before kickoff, first announced that they were going to use April tags. So we launched a project to make sure we know how to use it properly before the kickoff. And since Limelight launched so late, we stick with photon vision because we knew it well. So this is the East Limelight. After our, after our second competition, we added this Limelight because we saw that this Limelight doesn't cover enough field of view for us. So when we want to place a cone at specific nodes, this doesn't always see an April tag, and the odometry doesn't give accurate enough information to base our autonomous placement off of that. So we always need to see a vision target. So in order to do that, we added this limelight, which searches for reflectors, and how we do it is we use the gyro to align ourselves to the grid. We move left and right until the reflector is perfectly in the middle, and then we drive straight until we detect a bump and place we place the cone on the grid. We have another camera here on the back if you want to count. It's an Intel RealSense T265.
You guys have more cameras back here.
Yeah. It's perfectly located to have as large of a field of view as possible and be protected while at it. So it's connected to a Raspberry Pi that serves as a translation layer for the RoboRio. We fuse these three sources, the odometry and gyro, April tags, and this camera to have the best knowledge of where the robot is on the field. After we know where we are on the field, we have the keyboard over there, which we use for me as a second driver to tell the robot where to go. It knows where it is on the field. We use actually Path Planner to make a path from where we are, which is supposed to be somewhere in the community already, not in the middle of the field, and go to the grid to autonomously align the robot to place our game piece. Do you want me to talk about the keyboard?
Yeah, tell me more about this keyboard.
Okay, so
you guys have a keyboard as like the controller. How does that work?
Yeah, so I'm assuming you haven't seen a lot of teams use a keyboard to control the robot. I'm guessing you did see lots of teams use actual buttons. So Me as a programmer, I saw that we're going to have to need a lot of buttons to tell the robot where to go, because there are a lot of positions that the robot can go into. So what we did is actually use a virtual device on the driver station, and running a Python script that reads the buttons and translates them into an HID device for the driver station program. So that allows us to basically use every button on the driver station as a controller.
Well, TRIGON 5990, congratulations on the great success you guys have had this season so far. I know you guys won't be here on Saturday for Shabbat, but overall, congratulations on your great success, and I wish you guys the best of luck in your future endeavors.
Thank you so much.
This video on First Updates Now is made possible by viewers like you and also the following sponsors. SOLIDWORKS is free for first teams. Over 80% of US engineering schools and 370,000 plus companies use SOLIDWORKS to design great products. SOLIDWORKS can help you design a great robot on desktop or on the cloud. Go to solidworks.com/first to register your team. Don't forget to like, subscribe, and ring the bell to stay up to date on our new videos. Keep the conversation going and provide your input to our content. Watch our live shows at twitch.tv/firstupdatesnow. Join our Discord at discord.gg/firstupdatesnow, and check out Fun FTC on Facebook, Instagram, and Twitter, and First Updates Now on Facebook, Instagram, TikTok, and Twitter.